Now when it comes to adding vectors, I can add them in two different ways. That is visually, and that is mathematically, using math. Alright? Now adding a vector, you are going to get a vector out of it. So if we add vector 1 plus vector 2, we are going to get a third vector. Okay. And now, with that concept in mind, I'm actually going to talk about adding vectors. So I'm going to define vector 1 as having two components, an x and a y component, of 5, 2. Okay. Our second vector, vector 2, is going to have an x and y component as well. And it's going to be 5, 4. X and its y component. Now fundamentally we could add a third component in there, but I am going to only go over x and y component because if you add that third component in there, you're just adding, they're fundamentally the same if you add them. So first of all, I'm going to show you that when I add these two vectors together, I get a third vector. That is because vector 1, I'm going to do this in colors. So make it start off with a vector 1 is equal to, all right, 5, 3 plus a vector 2. I do not know why I put that there. Plus vector 2 is going to give us 5, our x component, a y component, 4. Okay, and this is going to give us another vector, because when you're adding two vectors, or 3 or 4 or 5 vectors, you get a vector out. So you want to add the individual components together. So this is going to give us, simply enough, it's going to give us 5 x hat plus 5 x hat. And of course I failed to mention, x hat is basically, it's called a unit vector, so it has a length of 1. This just tells us that we're adding these two like components together. And likewise, when we add our y components, so plus 3 y hat plus 4 y hat. Like in algebra, when you see an x and a y together, you can add them together, and you're going to end up with, put that in red, we're going to end up with 10 x hat, okay, plus that blue, 4 plus 3, 7 y hat. Okay. Now, as you notice that you have these two terms right here, which sometimes it can get confusing, okay, because, I mean, only occasionally it gets confusing, but you can rewrite this as, put my red back, 10, 7 as your new vector, as vector 3. This is because these special unit vectors here, that the x hat and the y hat, are basically multiplying this by 1 for the x component. And this y hat is basically multiplying this 7 times 1 for the y component. So if you had another on here, as in a z hat, your z hat would make it add a third component onto this, giving you 10, giving you 10, 7, 1. Okay. If you had a t hat, maybe for time or something, you'd add a fourth component onto this, so you'd get 10, 7, 1, 1. All right. So these unit vectors can assist you in addition to get another vector out, and they can also assist you in writing complex formulas when it comes to adding, subtracting, or multiplying vectors. Now, You can also add a vector another way. So we can add it as in 5, comma 3. I want to write it like this. So 5, comma 3 plus, okay, 5, comma 4. That's not blue. 5, comma 4. Okay. Now this just means that you add the individual components together. So 5 plus 5 will give you 10. That's not red. Will give you 10. Okay. Then adding the 3 and the 4 together, again, will give you, that's not blue. Will give you 7. Okay. So we got the exact same vector out. So our third vector came out the exact same way, okay, as this method right over here did. They're just different methods of adding vectors together, and the concept of subtracting a vector is pretty much the exact same. So if you wanted to subtract these two vectors together, I would get 5, comma 3 minus, I would get 5, comma 3 minus 5, comma, okay, 4. Alright. Which this would equal 0. So 5 minus 5 is 0, comma 3 minus 4 will give you a negative 1. Give you a negative 1. Alright. This definitely just changed the direction of the vector. So typically when you subtract vectors, the resultant vector is going to be changing in a specific, I mean, even when you add them, their directions are typically going to end up changing. So after you add them visually or mathematically, okay, we can also add these vectors visually. So I'm going to go down here, and I'm going to make a really big grid. Okay. Then I'm going to have one vector here. Okay. And this is going to be we're going to call this vector A. Alright. So vector A plus vector B should give me vector C. So I should come out with another vector. So with the concept of adding two vectors, we're going to have another vector. We're going to call this one C. So I'm actually not going to give any coordinates for this, but I will show you that when you add them up together, they do give you a resultant vector with respect to with respect to a triangle. So these two vectors. Now, when it comes to vectors and plotting them on a Cartesian coordinate system, you can actually move a vector anywhere you want. So when I add these two vectors, A plus B, I want to move this vector head to tail. So I want to move this tail to this vector right here. So I'm going to move this guy, and he's going to give me this vector. Okay, it's going to be pointing in the same direction, and it's going to be the same length, same magnitude. Okay. So this is my vector B. Oops, this is my vector B. And this is also my vector B. Okay. Now, since I added these two vectors together, the resultant is going to be visually this vector. So from the origin to the head of vector B from vector A will give me this resultant vector right here. Alright, so this is my vector C. Now, if we wanted to put numbers in for all of this, and we wanted to prove this, alright, we can say that vector A, alright, I'm going to go down further, give this a new screen. So we can say that vector A, right, we're going to say it's going to be over here, so I'm going to have this vector going in this direction. Alright, vector A is going to be, we'll say he's at 3, 1. Alright, and if we wanted to add the next vector, we're going to say, so vector 1 is going to be equal to 3 comma 1. Vector 2 is going to be equal to 1, we'll say 1 comma 1 for vector 2. Okay, so it's going to be at a 45-degree angle since it's precisely going to 1 comma 1. Alright, so I want to add 1 comma 1. So 1 comma 1. Alright, now when we add these vectors, we should get 4 comma 2 as our resultant vector. So vector 3 should be 4 comma 2. Alright, using the mathematical skills that we just developed up here, adding our vectors, we can now add these vectors visually, or we can add them mathematically plus visually. So I'm gonna actually move this vector 2, okay, this vector 2, vector 1, on the head of vector 1. So I'm going to get this vector right here. Okay. So since I moved him, his position is definitely going to change. Alright. Now the direction stays the same, but you can move a vector anywhere you want. So this position. Now to get where this was, we know the slope is 1, 1 here, so we go up 1 over 1. So our resultant is going to be 4 comma 2, which makes sense because now when we draw our resultant vector, we're going to get 4 comma 2 for our vector 3. And that's how you add vectors visually.